What's up, y'all? This is Tom, and this is Like a Math Class. In this video, we're going to talk about special derivatives. What I consider special derivatives are trigonometric and natural logarithms and the e to some power or some function. So we're going to look at those and see how they apply to our IB curriculum. Let's get to it. There are 4 special case derivatives that you need to know exist. And that's really it. You need to know that they exist. So if you ever see that you are taking the derivative of one of these 4 functions, that you go back and you check your formula booklet because you want to know how to use it and when to reference it. The 4 special cases that we need to know are if your function is sine of x, then the derivative is cosine of x. And if your derivative is, or if your function is cosine of x, then your derivative is negative sine of x. And you can easily see why, how closely these things are related, that you might actually get this mixed up, which is why I say don't worry about it, don't memorize it, use the formula booklet. The other 2, these you might remember because they're a little bit more, they stand out a little bit more. If your function is e to the power of x, then the derivative is just e to the power of x. There is no change in that. And that will be something that maybe we can cover in a future video. The other one is the natural logarithm of x. So if your function is the natural logarithm of x, then your derivative is 1 over x. All right, so let's take a look and see how some of these things come into play. Let's work through an example together. And actually, you know what I'm going to do? I'm going to color code these just so we can easily find them as we know what we're going to reference. So I've got the yellow for our function being sine. I've got purple for our cosine. We'll do green for our e of x and red for our f of x. The example says, find the derivative with respect to x, the derivative of y with respect to x, for y equaling sine x minus 2 cosine x plus 3e to the x minus ln x to the 4th. All right, so let's color code these and let's see what we come up with. So y equals sine x. And then we have minus 2 cosine x. So there's our purple, our green for 3e to the x, and then finally minus ln x to the 4th. Here's something you may want to do. Pause the video, work through this, and see if you match what we come up with together when we play it back. So the derivative of y with respect to x, let's take a look. The first thing, the derivative of sine x. The derivative of sine x is going to be cosine x. So here we go, we've got cosine of x. And then we're going to use our constant multiplier rule. We've got minus 2, so there's our minus 2. And we know if our constant multiplier rule, if we've got a constant times a function, we take that constant and we multiply it by the derivative of that function. So the derivative of cosine is negative sine x. So then we've got a minus sine x here. And then we're going to add 3 times e to the x, so plus 3 times the derivative of e to the x, which is just e to the x. So there's our derivative, and the derivative of ln x to the 4th power. I bet you were thinking that there was going to be a chain rule for this. This one gets a lot of people. Let's go back to our logarithm rules and see what happens with ln of x to the 4th power. If you go back to your logarithm rules, you'll remember that if you've got ln of x to the 4th power, then that is the same thing as bringing this 4 out here. So our function itself is actually equivalent to 4 ln of x. So it's not a chain rule here. So what we actually have is 4 ln x. That's what this piece is right here, right? So this is what we're actually taking the derivative. So we're going to subtract 4, and then the derivative of ln of x is 1 over x. So we're going to multiply that by 1 over x. Now we just simplify and we are good to go. So this is going to be equal to cosine of x plus 2 sine of x. Remember, minus and a minus is our positive, plus 3e to the x plus 3e to the x minus 4 over x. You could also put, if you wanted, you could make this thing 4x to the negative 1 power, and that would also work for you. This is our solution, our derivative with respect to x. Here we go. That's it. All right, we've got one more example. This example says find the gradient of this whole mess when x equals 0. First thing I want you to do, hit the like button. Second thing I want you to do is work this problem out and see me in the next video where we work it out together. I'll see you there.